All right, let's go through this. So, all right. You have this many grams of silver reacting with this many grams of hydrogen sulfide, aka hydrosulfuric acid. Which reactant is limiting, which is in excess? So there's a couple ways to do this, but the easiest way is to just do two calculations and see which one gives you a smaller amount of product. So I'm going to randomly pick a product, maybe this one just because it's got an easier molar mass. Whichever one of these makes less product is the limiting reactant. So because it doesn't specify a product, I'll just pick this one just because it's simpler to calculate its molar mass. Because after all, hydrogen is 1.008 grams per mole, and H2 is twice that to make 2.016 grams per mole. Silver, so that's H2. Silver is something we can look up on the periodic table. Its molar mass is 107.87 grams per mole. And H2S, let's see, I guess I'm running out of space. I didn't plan this very well. Is 2 times 1.008, because that's hydrogen, plus sulfur is 32.07. 32.07 equals 1.008 times 2 is that, plus 32.07 equals 34.09 grams per mole H2S. Remember, round your molar masses to the hundredths place always, unless it's hydrogen, unless it's pure hydrogen. All right, now, okay, that's our molar masses. Now, wait, why did I do that? Because if we want to find limiting and excess reactant, that's a stoichiometry question. That means we need to relate one chemical to another different chemical. So what I'm going to do is I'm going to go from grams of reactant to moles of reactant. That's why I needed the molar mass of each reactant right here. To moles of product. Moles of product, reactant to moles of product means the balanced equation, so that's what this is for. And then I'm going to take moles of product and convert it to grams of product. So, all right, let's write our two reactants. So 42.5 grams of silver and 46.1 grams of H2S, which is, again, hydrogen sulfide. Depends on the state. If it's dissolved in water, then it's hydrosulfuric acid. If it's a gas, then it's hydrogen sulfide. All right, but regardless, we're going to take this and go through this calculation. So we're going to do both of these. We're going to go from, okay, oops, made a mistake, so let me fix that. So anyway, we write down what our given is, and we're going to go through this process. So we're going to go from grams to moles. So I'm going to write grams of what we're given, be it silver or H2S, and go to moles of what we're given. So moles of H2S for this bottom one, moles of silver on top. And then from there, we got to put the same thing down here so it cancels. So moles of silver for the top calculation, moles of H2S for the bottom calculation. And then we're going to go from moles of what we're given to moles of what you're trying to find. We're trying to find H2 because it's easier. So I'll put moles of H2 on both because we're going to see which one makes less H2. And then the next one is going to go from moles of what we're trying to find to grams of what we're trying to find. So same thing for the top one, moles of what we're trying to find to grams of what we're trying to find. By doing it this way, moles of H2 cancels moles of H2, moles of H2S cancel moles of H2S, grams of H2S cancel grams of H2S, so we get grams of H2. And up here, same thing, grams of silver cancel grams of silver, moles of silver cancel moles of silver, moles of H2 cancel moles of H2. So they'll both give us grams of H2, and we'll see which one gives us a smaller number. That will tell us the limiting reactant. So let's look at how we actually put the numbers in here then. So silver, 1 mole, according to this, has a mass of 107.87 grams. For H2S, it's 34.09, so 1 mole is 34.09 grams. Balanced equation tells us, let's see, there's a 1 next to the silver. There's a 1, or should I say there's no number, therefore a 1 next to the silver. No number for the H2S. Or wait, is there? Oh, no, we forgot to balance. Okay, let's actually back up a sec then. So silver, 2 silvers, let's put a 2 here. 2 hydrogens, 1 sulfur, 1 sulfur. Okay, so now it's balanced. Woo, okay, almost missed that. 2 next to the silver, and then 2 hydrogens. Okay, so we're confirmed that's good silver. That's just 1 mole of H2S, 1 mole of H2. All right, and then we can kind of just, well, go on from there. So that's it. It comes from the balanced equation, the numbers that go here. And then this is the molar mass. Molar mass of hydrogen is 2.016 grams per mole, so 2.016 grams per 1 mole. Oh, so 2.016. That's a decimal point, I swear. All right. Now, that means this divided by this divided by this times this. This divided by this times this will give us our answer in grams of hydrogen. We'll see which one makes fewer grams of hydrogen. That's our limiting reactant. 42.5 divided by 107.87 equals, divided by 2 equals, times 2.016 equals 0.3971 grams of silver. That is not rounded for, sorry, I don't know why I said silver, H2. But anyway, this is not rounded for sig figs. We don't care. We're just trying to find out which one makes a smaller amount. Technically, it should be 3 sig figs. So, all right, I guess I'll be good. 3 sig figs. Because that's more than 3, that's infinite, that's 4, so 3 sig figs it is. So, okay, I guess I'll round the next one to 3 sig figs too. All right, 46.1 divided by 34.09 equals times 2.016 equals 2.73 grams of H2. Clear this made less, which means this tells us that H2 is the limiting reactant. So I don't know, sorry, I don't know why I just said that. This is less. I don't know why I just said H2 is limiting reactant. It's not a reactant, it's a product. But the thing that led to this here is the limiting reactant. So because this produced the smaller answer, this becomes the limiting reactant. So Ag is limiting. All right, so that's how you can pick a product and use it to figure out your limiting reactant. Now, if I had picked Ag2S, which is silver sulfide, that would have worked too. It would have been slightly more work to calculate its molar mass, but if I had put moles of Ag2S and grams of Ag2S, this would have produced more grams of silver sulfide than this one, so this still would make the smaller number and would still have been given you that this is the limiting reactant. All right, now, that's one way to go about it. Now let's look at how you go about doing this one. Again, we're given information about one set of chemicals and asked about a different chemical, so that's stoichiometry. We're going to need a balanced reaction. We're going to need to do mole-mole conversions and gram-mole conversions. And we're given 2 reactants, so we know we have a limiting reactant situation. We're going to do 2 calculations and pick the calculation that gives us the smaller answer. So, first things first, we got to do that balanced reaction. So it says calculate the mass of this made, so there's a product, if that reacts with that. So we got a situation where lithium plus nitrogen reacts to make lithium nitride. Let's balance that. So that's 3 lithiums, 2 nitrogens. Oops, I don't know why I wrote the lithium nitride like that. So Li3N. So that's 2 nitrogens, that's 1 nitrogen, so let's put a 2 here. Now it's 2 nitrogen, good, but that's 6 lithium, so let's put a 6 right here. Now 6 lithium, 2 nitrogen, we're balanced. Having done that, now we need to add up some molar masses. So let's go ahead and do that then. So we are going to be looking at lithium, straight off the periodic table, rounded to the hundredths place, 6.94 grams per mole. Nitrogen, that's 2 times 14.01. It's right there, 14.01 is what that rounds to when you go to the hundredths place. Equals 28.02 grams per mole. And then for lithium nitride, that is 3 times, actually, let me fix that. Okay, there you go. 3 times 6.94, because you got to round it to the hundredths place, plus 1 nitrogen is 14.01. So 3 times 6.94 plus 14.01 is 34.83. That's your molar mass of lithium nitride. Okay, we've got about everything we need. We are going to go from grams of reactant, because that's what we're given for each. Well, I need to convert this to grams, by the way, to moles of reactant, to moles of product, but the product is specified this time, so it's lithium nitride. So moles of lithium nitride to grams of lithium nitride, because that's what it's asking for. It's asking for the mass of lithium nitride. So I did mention that this needs to be converted to grams. And notice everything's in grams, 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 grams per mole. This has to be converted to grams because milligrams cannot cancel with grams. So 5.60 times 10 to the third milligrams times milligram on bottom, gram on top will give you an answer in grams. So M2, that many milligrams, whatever, actually doesn't matter. But I want to get at, this is going to be 5.60 grams. But how do I know that? Because a milligram is 1/1000th of a gram. So the number 1,000 goes in this conversion factor. And since it goes next to the smaller unit, milli is 1/1000th, so we put 1,000 down here. 1 gram is 1,000 milligrams. We're going to take this divided by 1,000. That's 5.60, but I'll prove it to you. 5.60 times 10 to the third divided by 1,000 is 5.6. Now, 5.6 is what the calculator says. You make sure you say 5.60 because you have 3 sig figs here. You need to maintain your 3 sig figs. So that is your N2. So let's write our givens. We have 5.60 grams of N2. We have 56.0 grams of lithium. We're going to do 2 calculations and pick the one that gives us the smaller answer. We're going to follow this. Grams to moles of what we're starting with, to moles of what we're trying to find, to grams of what we're trying to find. So let's do it. So from grams of N2 or grams of lithium to moles of lithium or moles of N2. From moles of N2 to moles of Li3N, from moles of lithium to moles of Li3N. And then from moles of Li3N, same thing here, to grams of Li3N. Okay, why it's set up like this? Grams of lithium cancel grams of lithium, moles of lithium cancel moles of lithium, moles of lithium nitride cancel moles of lithium nitride, giving you grams of lithium nitride in the answer. Same process applies here. Gram of N2 cancels gram of N2, mole of N2, mole cancels mole of N2, moles of lithium nitride cancel moles of lithium nitride, leaving you grams of lithium nitride. Whew, that's a long one. But we need to fill in the numbers. Grams and moles, that's molar mass from here. A mole of nitrogen is 28.02 grams. Lithium, a mole of lithium is 6.94 grams. Remember your molar mass is still hundredths place. From the balanced equation, lithium nitride has a 2 next to it. Nitrogen has no coefficient, so I put a 1. Lithium has a 6 next to it, so I put a 6. And then the molar mass of lithium nitride, 34.83 grams. Oops, 0.83. So 1 mole has a mass of 34.83 grams. 1 mole has a mass of 34.83 grams. Woo! This divided by this times this times this. 5.60 divided by 28.02 equals, times 2 equals, times 34.83 equals 13.92 blah blah blah. So it's 13 point, oh, what are we going to do? 1, 2, 3, 4, infinite, and 4, so 3 sig figs it is. 13.9 grams of lithium nitride. Don't box this answer yet. You don't know if it's the smallest one. All right, now let's do this one. 56.0 divided by 6.94 equals times 2 equals, divided by 6 equals, and then times 34.83, giving 93.68, 93.7 grams of lithium nitride. We're going to choose our smaller one. This is the smaller one, so that is the amount of lithium nitride produced in this reaction. All right, so having done that, let's look at another one. Now we're going to look at the same thing, except how many grams of excess reactant remains. So we got to do the same as we did before, and then subtract out what's left over, subtract out how much is used out of your excess. So what we do is slightly different from the previous one though, because instead of trying to calculate amounts of product, we're instead going to calculate how much each reactant uses of the other reactant, which means we still need molar masses, and we still need to do gram to mole, mole to gram conversions. We still need to do a molar balanced equation also. So the setup is 48.5 grams of copper metal react with silver nitrate. In case you know how to figure that out, silver is a plus when it becomes an ion. Nitrate is a 1 minus charge. So you get 1 silver and 1 nitrate in the formula, so it looks like that. The reactant makes silver and copper 2 nitrate. So silver and copper 2 nitrate. Copper with a 2 plus, nitrate with a 1 minus. So if you switch those charges, you get 2 nitrates and 1 copper in the formula. So that's going to be 1 copper and 2 nitrates in the formula, like that. Okay. Now to balance that, there's 2 nitrates, so I've got to put a 2 right here, which means I need to put a 2 right here. So it's 1 copper, 2 silver, 2 nitrates, and 2 nitrates. So we're good. That's balanced. Now we're going to be working with silver nitrate and copper metal. We need to figure out their molar masses. So for copper, that's straightforward. You just look at that off the periodic table. Copper is 63.55 grams per mole. As for silver nitrate, is, let's see, silver, here we go, 107.87 plus nitrogen is 14.01 when you round to the hundredths place, plus 3 times oxygen. Oxygen is 16.00 when you round to the hundredths place. Let's figure that one out. Oops, get my camera steady. Okay. 107.87 plus 14.01 plus 3 times 16 is 169.88 grams per mole AgNO3. All right, I should make that a clearer letter N. All right, there we go. So that's that. Remember, always the hundredths place for those molar masses. Now we can do this. So what we're going to do is calculate how much each reactant needs of the other reactant. So I'm going to start with my 48.5 grams of copper and my 75.4 grams of silver nitrate. And I'm going to go, as we usually do, because we're doing from one chemical to another, we need to use a mole conversion to go from convert grams to moles of this to moles of the other thing, and then moles of the other thing to grams of the other thing. So let's look at what that looks like. So grams of copper goes on the bottom, moles of copper goes on top. I'm going to just focus on the first calculation first. From moles of copper, we then go to moles of the other reactant, because we're going to see how much each reactant needs of the other reactant. So moles of AgNO3. And then I'm going to go from moles of AgNO3 to grams of AgNO3. I'm going to see how many grams of silver nitrate are needed by this, and see how it compares to the grams we actually have. Same deal for this one. I'm going to go from grams of AgNO3 to moles of AgNO3, and then from moles of AgNO3 to moles of copper, and then from moles of copper to grams of copper. And I'm going to see how many grams of copper this needs and see how the grams of copper needed compares to grams of copper we have. Let's fill in the numbers. Copper, molar mass when you get grams and mole. 1 mole is 63.55 grams of copper. Let's do the same thing. 1 mole is 63.55 grams of copper. Moles and grams for silver nitrate. Silver nitrate is 169.88, so 1 mole is 169.88 grams of silver nitrate. A mole of silver nitrate is 169.88 grams. Sorry, I can't even talk. 1 mole of silver nitrate is 169.88 grams of silver nitrate. So I fill in the molar mass for each. Now we need to do the mole-mole ratio. That comes out of here. Silver nitrate has a 2 next to it, so I put a 2 next to moles of silver nitrate. Copper doesn't have anything, so I just put a 1. So let's do this. 48.5 divided by 63.55 equals, times 2 equals, times 169.88 equals 259. Sure, let's round for sig figs. 3 sig figs, so that's just 259 grams of AgNO3. So we need 259 grams of silver nitrate. Oh, we need more than we have, so I can already tell silver nitrate's our limiting reactant. All right, let's do the other one though. 75.4 divided by 169.88 equals, divided by 2 equals, times 63.55 equals 14.1 grams of copper. So we need 259 grams of silver nitrate, but what we need is more than what we have, so we're going to use up all our silver nitrate with nothing left. We need 14.1 grams of copper, and we have 45.1. So what we need of the copper is less than what we have. So copper is the one we're going to have left over because we have more than we need. So I'm going to do that. I'm going to say we have 48.5 grams of copper minus needing 14.1 grams of copper. What does that leave? 48.5 minus 14.1, 34.4 grams of copper left over. Okay, that's how you go about figuring the amount of excess reactant that remains. Now, your final answer to the final thing here, how many grams of limiting reactant remain, I'm going to address that by looking at this. Your limiting reactant is the one that runs out. So there's 2 reactants, copper and silver nitrate. We need more copper than, we need less copper than we have. So copper is the excess reactant. That makes silver nitrate the limiting reactant. If you need 259 but only have 75.4 grams, you're going to use it all up. There is nothing left. So my answer to this one down here is you do not even need to show any work, because the answer is always the same. How many grams of limiting reactant remain? None. Ever. And there's no exceptions to that. If it's a true limiting reactant, there is never anything left. You can just say no grams of limiting reactant remain ever, because that's the definition of what a limiting reactant is. It runs out. That's it. 0. There you go, ladies and gentlemen. That shows you how to do the stuff that you got to be able to do.